So I'm in a biomed class at school, and through the biomed class we can become base certified, which is a certificate you need to like to do to work in a lab to do research and stuff like that. So I took the test last year during the summer, or no, last year like in March, and I just got my certification today, like literally 5 minutes ago.
Oh, congratulations.
But it's with you.
Wait, that's a biomedical, right?
Mhm.
Yeah, I think
It takes forever.
my friend started this program, and so I think now you can work on as a lab assistant, right? Yeah. So my friend helped start with this program, which is Mr. Davis is a good friend with my other friend,
Uh-huh.
Patel from a different school. And they both run Science Olympia. I think Cyprus kids gonna come here compete.
Everybody's coming here. We're hosting.
Yeah.
We're hosting.
So, but they are good friend with each other, and they kind of developed this program. But yeah. Okay, so what we're gonna talk about what is speeding up versus slowing down. Okay. Speeding up versus slowing down. So the way easiest to think about is this. You don't have to memorize it. Um, but the thing to think about is if the signs between velocity and acceleration are the same, therefore you're speeding up. So it can be acceleration is equal to positive, velocity is equal to positive, or acceleration equal to negative, acceleration equal to negative. They all speeding up. And we're going to explain that what it is. So signs between velocity and acceleration are opposite. Are opposite. So for example, a is equal to positive, velocity is negative, a is negative, velocity is positive. So if they are opposite to each other, they are slowing down. Now we're going to give you a situation of a stop sign. Okay, so we're going to create a rule that this is some type of road. Okay, and this is some type of road, and some type of road. Okay. There is a stop sign here. There's a four-way stop. So there's a stop. And so there's a stop here. Okay, so there's stop sign from both sides of direction. So we have a one car that's driving toward school. Let's just say this. And we're gonna assign this is we're gonna assign the whole thing is the both acceleration and velocity has a vector. So this one is a positive. So in this case is negative. Are you following me so far? Is if you're going right is positive, going left is negative. That's the only thing we establish. And you have to establish that first because you have to say which direction is positive, which direction is negative, right? So imagine me driving the car, right? What happens when I see, if I'm driving this way, right? What happens if I see a stop sign?
You're gonna start slowing down by like decelerating. You press the brake.
Okay, so that now let me ask you. Is my velocity positive or negative here? of this car, my velocity is positive or negative? Yes, Caroline? Don't know? Katie?
Isn't velocity positive?
Is it what?
Positive.
Okay. Velocity is positive. Good. Good. Um, but what do? We see the stop sign, we what?
So that acceleration is good.
You press the brake, right?
Mm-hmm.
You don't press the gas. And that's your mystery here. Wow. Okay. You press the brake, right? The brake is decelerating. So the brake is pulling the car backwards. Does that make sense? So you got V is a positive, acceleration is negative. So that's why you're slowing down here. Right? Now, what after the stop sign, your car has no more stop sign. Just keep on going. You can go straight to school now. Now, what's my velocity? My velocity is still positive. Does that make sense? And you press gas. So that's positive. So the direction makes completely sense. And this is speeding up. Now, some people say, well, what if I'm driving on the way back to school? A good analogy would be driving backwards, but of course now it's not possible to drive backwards, reversed back, unless you're in Fast and Furious. So what happened if this car is driving back, right? What is my velocity? It's positive or negative?
Negative with the positive acceleration.
Negative. Good. Now, of course, if I see a stop sign, what do I have to do? I have to decelerate. So here's my question. Is my acceleration positive or negative in this case? Is my acceleration positive or negative? It'll be positive? Why?
Because your velocity is negative when you're slowing down, that's the opposite.
Yeah, so you think about the result first. But what do you think? Is acceleration positive? Does that make sense? Acceleration is positive. Does it make sense? Well, the truth is acceleration is positive. Why? Imagine you have some car is running this way, right? And this car has no brake. Right? So I can go push this car backwards. So basically my acceleration is positive because I'm trying to slow it down. So I'm pushing the car backward. So my pulling, the force, it's actually going the opposite. Therefore, acceleration is positive because you go in that direction. You're pulling against the car. So, for example, like if I have somebody's going to a stop sign, but it's on the way home, right? So it's negative. Velocity is negative, and he's running so fast, and then I have to say, no, there's a stop sign. So I had to pull him in the back. Pull him, says, hey, you have to slow down to press the brake. So my pulling force is going to the positive directions. So therefore it's positive. Does this make sense or no?
So you're saying that there's like a pulling force, so some force is pulling the car this way.
That's why you're slowing down. You had to pull in the opposite direction. That's why you're slowing down.
But then when a car is going forward, it's going with the pull, so you don't have that effect.
You have that effect. You have to slow down the car. Just imagine you going, there's a rolling car, right? And it's going to the opposite direction. What do I have to do? I have to go catch the rolling car, start pulling backward as much as you can. But that force is our acceleration going this way. My acceleration is the opposite directions. So they have to cancel out each other by velocity acceleration. They have to cancel out each other in order to slow down. Dev, does that make sense? Sarah Jo? Yes? Yes? Sydney? Don't just nod. If you don't understand, Paige asked me like 20 questions last period. And it's okay. I'd rather you ask me 20 questions. No. It's okay to ask questions. Caroline, does it make sense? Okay, so after the stop sign, this car is going this way, going this way. So my velocity is negative. My acceleration is also negative because I'm pushing that way now. So acceleration has a direction sense just as much as a velocity. Now, this caused a lot of confusion for a lot of students today. I say speed is equal to absolute value of velocity, and that's caused a lot of confusion for this particular questions. For this particular question says this, number 8. A particle moving along x-axis let the position at any time is given by x of t of t to the 3 minus 6t squared plus 9t plus 12. And you're like, huh? I don't know about this one. So what we're gonna do is, of course, we're gonna find the relationship between velocity and acceleration. So velocity is equal to 3t squared minus 12t plus 9. And a of t is equal to 6t minus 12. And what we're going to do is we're going to do some type of number line. And it's 2 because this one is going to be t equal to 2 is equal to 0. So this one's going to be negative and positive. And if I do this one, if I factor out 3, so it's going to be 3. It'll be, I think, is 1 and 3. So it's 1 and 3. And this one's going to be negative, negative, so it's positive. Sorry. And this is negative, and this is positive. So positive, negative, positive. Now they say is speeding of a particle is increasing. That means I'm speeding up or slowing down. Speed up, right? So if I speed up, what will happen? Well, speed up is you're looking for the same sign. It turns out in the first seconds here, you have an opposite sign. Do you see that? Now between 1 and 2, what will happen? This part is negative, and this part is negative. Does that make sense? So therefore, between 1 to 2 is right. And then from here to here, guess what? It's opposite. So it's slowing down. But I here is what? Speeding up. So the answer is B. Do you guys see that now? You compare two number lines and you check what happened to the sign. Are we lost? Are you guys get it? Katie, do you have a question? You have a question?
No.
Yes.
How do you actually consider negative?
Huh?
I said, just how do you actually consider negative velocity?
Negative velocity? I don't actually comprehend the question. Negative velocity is like you drive into Miami, it's south, it's negative, therefore it's a negative velocity. You drive into New York, it's a positive velocity.
So it's just in relation to whatever direction you're going.
And you have to assign which direction is positive. So you have to say going north is positive. Usually a particle is going right and left. We assign right is positive, left is negative, like a number line.
But you'll still receive the point as long as you explicitly say like which direction is which.
Yeah, but we always assume going right is positive, going left is negative. That's what we assume. Like we've been building that habit since the number line.
No, but like for the test, do we have to explicitly like state like right is positive, left is
No,
or-
no, you don't have to write that. They know that you are assuming that part, and that's a part that is usually what happened, right? Going up is positive, going down is negative, and it's just the way it is. So that's the fundamental difference that you guys have to understand. So there was some question that it's a kind of like a debating. So I personally not big fan of question 13 nor question 2. So and they are similar question. They usually don't ask question this way, and I really don't think it's a very good questions because they usually ask in terms of speeding up or slowing down.
So they're talking about speed when they're talking about velocity in 13, but velocity and speed are the same thing.
Well, so here's a part a lot of people confuse, right? So yesterday we said speed is equal to absolute velocity, right? So we spent whole period talk about this. So people says, well, can it just be positive because this one is positive because this is absolute value, right? Does that make sense? So it's just absolute value on negative side makes this positive. But the things about speed is speed. Speed you don't have to consult with the acceleration, but the slowing down or speeding up, you have to look at accelerations, and you cannot look at the sign. And you look at the result of velocity and acceleration first before you absolute value something. So you look at the result. The result is speeding up or slowing down. We're not looking at what's the speed. We're looking at the speed increasing or decreasing. Then you have to consult with the accelerations. And we spend a lot of time talk about this. Why is that? It's just because speeding up you have to look at the difference. Okay, so now this is great. We're gonna go back to look at different questions. We're gonna look at
Can you upload this?
yeah, of course. This is a whole packet that talk about motions. And it has all the good information. This is actually a teacher's packet, but I use it anyway. So we're gonna talk about question 8. Now we said left is what? It's negative or positive. Yeah. So in this case, in terms of left, they are looking at the absolute minimum. And the key thing why I say absolute, why did I say absolute? Yes, furthest to the left. So let's think about absolute. So a lot of time when they say furthest to the left or furthest to the right, you have to consider what?
Maximum and minimum.
That, but what do you have to consider besides that? What?
If it's positive or negative.
No. Endpoints. Not only critical points, but the endpoints. You have to compare. Remember, on AP exam, wants you to compare by table, via table. So this is the time that if it's on the FRQ, then you have to compare to table to show justification. Now, this is a case that where some students like, I don't know about this one. So how would I do this? Well, I can always plug in, right? That's that can be the first goal to plug in. So let me import it to adding to existing nodes, motion, yeah. Next, import, done. I have so much things there. I need a probably bigger storage iPad. They're gonna run out of storage soon. So in terms of this, that you really need to consider endpoints, right? So usually I will consider t, and this is the x of t, and I'll compare 0. Of course, 0, I'm going to get 3. Of 10, I'm going to get what? I have no idea. Can somebody work out? To what? Can somebody use calculator to double check? How do I double check? I can type in the functions. I mean, of course, you don't have calculator, but I don't want to do this one. That he says 253. We don't know, so we're gonna say it's x. Not like I don't trust him, but I just want to be very precise. Minus 9x squared, plus 15x, and then plus 3, and I just. So that's just gonna var function 1 of 10. It's 253. Yep, thank you. So that's not furthest left. That's probably like furthest right? So then x prime of t, which is v of t, is equal to 3t squared minus 18t plus 15. So I think take out 3, so it'd be 3 squared minus 6t plus 5. So t minus 5 and t minus 1. I think 1 and 5. Usually this one's gonna give you negative, negative, positive, negative, positive. So positive, negative, positive. So which one is the minimum? It's 1 or 5. 5, right? So then I just plug in 5. Negative 22. Yay. D. Now, should you just do this part and not doing this part? Very risky. Because your furthest left could be at very beginning. Could be at very end. You cannot just say, okay, well, that's happening here. You can then just look at relative minimum and assume that's absolute minimum. You have to look at relative minimum as a candidate, and you'd consult with the endpoint as well. So those are the things that you should pay attention to. Yep.
Why do we find velocity for that?
Because we want to find out velocity. So in this case, that this is a 1, this is a 5. the thing is this traveling left and traveling traveling right, and this traveling left and this traveling right. But we need to know the velocity in order to find out are they the furthest left, because we want to consider this point by observing there's a negative sign here, because in order to go left, velocity has to be left at some point. And if velocity is left at some point, guess what? You can find out the information there. You can find out where is at end of the traveling left, what's my position is. Now you have to compare my beginning position and my end position to justify that is the furthest left. So furthest left is a little bit different. Got it? Does this make sense? Now this is gonna be part of your homework. You guys can try it. This is practice questions for the thing.